So in this first chapter, we're going to touch on the model view controller, which is going to be the ground base for the upcoming chapters of this game project, which is going to be a kind of Guitar Hero or Tap Tap Revenge sort of game where the player has to play different inputs in rhythm with the music. And so what we can see here is that the gameplay is a very data-centric gameplay. So it means that we're going to have to handle data for the tracks. And so we're going to have to author the data, and then we're also going to have to use this data. And in this chapter, we're going to touch on handling the data, creating some basic data. And what we see here is that we have a series of expected inputs are displayed as column, and so we're going to make it very simple for now, where we have just one input by one input, such as up, down, left, right. Then the display scrolls down with a set beat per minute parameter, and the player must press the buttons in rhythm with the music. And the input representations will change to reflect the player's action, such as did I miss, did I get it right, did I get it wrong. The player has to know if it's played right, and if it's played properly, he's got to get some rewards if he plays properly. So let's have a quick overview of what we're going to be touching on in this chapter. We're going to have a quick overview of the known patterns, which are the MVCs, which is the model view controller, or the MVVM for model view model, and the MVP for model view presenter, which are design patterns. Then we'll see how we can quickly mock up the view in Unity using the UI tools, so that we can give ourselves a pretty good idea, pretty good representations of what the view is going to be like, and then how the data is going to be like with it. Then we're going to touch on the track model. So we're going to touch on the data structure. We're going to make it so that the data is independent from the gameplay. We're going to touch on reusable data and touch on serialization. We're going to touch also on generating sample data randomly, so that we don't have to create our own data at the very beginning of the development. And we're going to touch on data display and editing as well. And then we're going to touch on the track view, which is representing the track in the game view using some display models that we're going to reference, and then we're going to populate the view with those prefab objects, and then we're going to animate the view. And later we're going to touch on the gameplay controller, taking the inputs from the player, handling all the gameplay mechanics. We're going to touch on the singleton pattern, which allows us to access a controller or access a game component wherever it is in the scene without having to manually reference it. And then we're going to touch on the beat views. Is what we want to do is to update the views when the player plays, so that the player knows if he's played right or wrong. So let's start with a quick overview of the model view controller. The model view controller tells us that we separate, as opposed to a component architecture. A component is self-sufficient, so components can work with each other's, but they are self-sufficient. So very often a component has its own data, it has its own representation of the data, and it handles the inputs from the player independently, so it's all self-sufficient. In a design pattern, we tend to separate things so that they're more modular, so that we can change things. The idea of a model view controller is that you can swap a controller very quickly and very easily without having to change another component of the ecosystem. In this pattern, what we see is that we have a model, which is the data itself, and on the other end there's the user, and in between there is a controller and a view. The view is, we'll take the model, we'll take the data from the model, and we'll present the data to the user in a given form. And then the controller, on the other hand, will take the input from the user and will modify the data. And so whenever the data changes, then the view updates, and so on and so forth. This is the model view controller. This is a design pattern that is widely used in apps development. Now there's a few other patterns that are very similar to that model view controller pattern, such as the model view model, where what you can see here is that there's a different layer of abstraction between the model and the view, where you have a view model, which is Okay, we know the data and we know the view, but what we want to do here is to make sure that you can have a view that somehow is able to adapt to a model. So you could have like a very generic view, and so a view could potentially display different kind of data, and this is the idea of the model view model, which is also used in game development sometimes. Another design pattern, which is again very similar to this, is the model view presenter. The model view presenter, as opposed to the original model view controller, you can see that the presenter is in between the model and the view. So it's not the view that really updates on the model, but the view updates based on the presenter. The presenter is the manager, it's the global manager, and it handles the data and gives the view, it gives it the data to be displayed, and the view will then display the data, and it will take the inputs from the user. So that being said, these are just design patterns. They're not just like something that you have to follow very precisely. It's something that you can play with and change as you need. Though it's usually good to know those design patterns properly and to understand them, so that whenever you want to create your own design patterns, then you don't end up in somehow recreating a pattern that already exists, falling in the traps of known design patterns. So with all that theory laid out, it's time to practice. And this is what we're going to do in the next video.